To Joe Academy, where learning becomes much more easier. It's been a long time we've had a class like this. So today we'll still continue with carbonyl compound under organic chemistry. We'll be studying for a while. So today we'll be looking at carbonyl compound. When we say carbonyl compounds, we're talking about the aldehydes and the ketones. The aldehydes and the ketones, they have a unique structural formula, and that structural formula, the empirical formula, is given to be CnH2NO. So, for example, if we say the number of the value of N is equal to 1 now, that is to say, the compound will have the formula C1H2O. So, this kind of compound is a carbonyl compound. They are also under organic compounds, the alkane. The difference between them and the alkanes is the presence of double bond. The presence of the double bond between the carbon and the oxygen. That's what makes the difference. So the carbonyl compounds are divided into what? The aldehydes, which are also called the alkanals, and the ketones, which are also called the alkanones. The difference is that if you have an alkane, you just remove the E and you put Al. And for the ketones, if you have an alkane, you remove the what? The E and you put ONE. So for all carbonyl compound, if this is a structural formula, then this kind of compound, the first one which is the first member of the compound or the functional group, is CH2O. The name for this compound is called what we call methanol. Methanol. That's the first member of the alkanal family. Then, in considering the alkanones, which are also called the ketones, although they have the same formula, but the structure differs. We have the same empirical formula for the both of them, but the structure differs. The difference is that for the alkanal family, they have a structure of this form: R, C, double bond O, R prime. And this R prime, for the alkanal, R prime is equal to H. But for alkanones, it has the structural formula R connected to C, double bond O connected to R prime, where R prime is equal to R and is equal to the alkyl. That is to say, R can be CH3, it can be C2H5, all the members of the alkyl family.